Hey guys, I'll be starting the video cast now for the Science Olympiad Dynamic Planet event. If you have any questions, I probably won't answer them during the video cast, but I'll set aside around 10 minutes at the end to answer general questions about the test. Um, um, yeah, so first I'll be talking about the general description of the Dynamic Planet event. Dynamic Planet is a written event. There are written events and lab events. Lab events will normally require experiments and such, while written events, you'll have the paper test and you'll answer the questions on the test as given. And since it is a written test, the test will be comprised of short answers and multiple choice questions. Multiple choice will have A, B, C, D, while short answers require your application of theories and laws. And short answers are also sometimes calculation problems, which the tests will sometimes have. Other times there aren't any calculation problems at all. Just make sure to bring a calculator regardless, just in case you have one. And regarding test length, the test length varies depending on the proctor issuing the test. It may be 50 or maybe 100 questions, and it completely depends on your proctor. But you'll have a partner, so you guys can just like split the test, like rip it in half, and then just remember to staple it together at the end so you can turn it in. And sometimes Dynamic Planet will be a timed station event where there are around 5 to 10 stations, and you'll have like a limited amount of time to answer and analyze whatever materials they have at each station. And then you'll have to answer questions regarding each material. Like they might have like a picture of a certain type of volcano. You have to identify the types of like its characteristics, or maybe like a seismograph. And then and you'll also have a separate like set of multiple choice questions that you'll already have, and then your other partner should be finishing that up, or you guys can like switch. So you'll have around 50 minutes total to do this test, and this year's topic is tectonics, which includes plate boundaries, earthquakes, volcanoes, etc. So that is a topic that you should be studying. And make sure to refer to the Dynamic Planet guidelines, and they should be available for you in the shared resource portal. So be sure to look at them because that's what your test will be about. So next, I will be talking about the parameters for the event, which are also on the guidelines. So each team or pair as a whole is allowed 4 sheets of 8.5-inch times 11-inch sheets of paper double-sided. So you'll have like 8 entire pages of resources and like notes or whatever you put on for you to use during your test. So it's like a cheat sheet basically. And then the font can be however small you'd like, but make sure that it is a font that is readable for you and your partner, since you will be the only ones who are going to be reading it. So it would probably be useful for you to make it a readable size or so. And you can also format the margins however you please. And make sure to organize them appropriately, so then it's like easier to access, since you'll only have 50 minutes to complete the test, which is really a time constraint. So efficiency is key. I also recommend categorizing everything based on their topics, and also bolding the titles of each category so it's easy to identify and find a section, and you can find the info under that section if you have it. Also, you should highlight or underline information that you think is important to remember, or like things that you anticipate might be on your test. And you should also include helpful pictures, diagrams, or charts just as reminders, like in case you forget, because um, it might be like a stressful situation. Oftentimes you might blank out, even if it's like an easy question. It's just nice to have that there for you. And if you still have extra space, like among the 8 sides, you should definitely fill it up. Since you're given the opportunity, might as well just put more on it. And like maybe you can go back on tests that you've taken in the past and on like questions that you're unsure about, or like you just didn't know in general. It'd be nice to like maybe jot down the answers and like the question format or so you can reference them during your tests, because sometimes proctors do like reuse problems or so they might have that again. And regarding utensils, you should have during the test, just bring like your pencil, pen, eraser, and maybe a ruler. Like if they require you to draw a graph, I'm not sure if you need to, but just in case. And also bring a non-programmable calculator. So no graphing calculators. Just bring a scientific calculator. It'll be pretty useful for the calculation problems that might appear on the test. And yeah. So now I'll go over the content of Dynamic Planet. So the general outline of the content is in the guidelines as well, which is in your resource portal. And it's listed as number 3 for the content. But for the specifics, you need to do your own research and gather your own resources. So I'll be talking about some suggested resources later, like near the end of the video cast. So first, you will need to know the history of plate tectonics and also the key scientists. So like I won't be going over all the points since there might not be enough time, but these are just like basic. You should definitely do the research on your own later. Okay, anyway, so you probably learned in 6th grade plate tectonics, right? So Alfred Wegener in 1912 published his theory of continental drift, which is basically like the movements of continents across plate tectonics throughout time. Wegener found evidence for this through fossils, like corresponding between like different like continents and such, and also geological landforms. Like they might have a glacier or something and its marks are on an entire different like continent, and then he'll know that they were probably together at one point. So the plate tectonics theory states that originally all of the continents were one large supercontinent called Pangaea, as depicted on the picture on the left. And Pangaea, like over like many periods of time, they just eventually broke up into the continents that like we know of now. And another key figure in an aspect was Harry Hess and Robert S. Dietz. They deduced the theory of seafloor spreading, which is the formation of new oceanic crust through the upwelling of magma at like a mid-ocean ridge. And then this newly formed oceanic crust then progressively drifts away from the ridge as time goes on. So the farther from the ridge, the older the crust, and the closer, the newer. You'll also have to know about layers of the Earth, as depicted on the picture on the right. You'll have to know the crust, lithosphere, mantle, and asthenosphere. So I put this picture because it might be easier for you to have a visual representation. And yeah, so first, the crust. The crust is comprised of a denser oceanic crust and also the thicker continental crust, meaning that oceanic crust is denser than continental crust, and but continental crust is thicker than oceanic crust. Yeah. And the oceanic crust is like on its own is approximately 6 kilometers thick, and it's primarily composed of basalt and lava as its top layer. And the continental crust, which is thicker and but less dense, is approximately 35 kilometers thick, and it's composed of like granite, sedimentary, and metamorphic rocks. The lithosphere, which includes the crust and uppermost solid mantle. Yeah, so it just includes the crust and the upper mantle. It's the pretty rigid outer layer. And then the asthenosphere, as depicted in this picture, is the upper layer of the Earth's mantle below the lithosphere, which is the crust and like the uppermost solid mantle. You'll also have to know about plate boundaries, which are convergent, divergent, transform, and also plate boundary zones. So convergent plates go towards each other as converging, as the word suggests. And when a continental and oceanic boundary converge, they form a subduction zone where the denser, but thinner, oceanic crust sinks below the continental crust. And when two oceanic plates converge, they form a trench. And when two continental crusts converge, they form mountains and similar terrains, like just like it goes upwards, not downwards, like with oceanic. Also, transform boundaries. Transform boundaries are when two plates slide past each other. Yeah. And another aspect that you should know are oligogens, which are basically failed arms of like a triple junction of a plate tectonics rift system. This triple junction, like that's supposed to form beneath, it's beneath a continental plate, and it'll initiate a three-way breakup of the continental plate. So it breaks up in three ways. You also have to know about hotspots, which you probably learned before in your science background. The most commonly known hotspot is called the Ring of Fire. You may have heard it. It's like in the Pacific. This includes the Hawaiian Islands, which are pretty active with volcanic eruptions. So the Ring of Fire, Pacific region, it's just a extremely active area where a lot of earthquakes and volcanic eruptions occur every single year. It's also important to know about the very prominent landforms created by plate tectonics, such as volcanoes, faults, earthquakes, and hotspots. Like, you might have to know the names, like Mount St. Helens, you probably heard about that, and then Yellowstone with its gigantic magma chamber, and just other landforms like that. And so, concerning earthquakes, you should know about P waves, S waves, and surface waves. So P waves, which stand for which are like basically primary waves, they're like the fastest. They arrive first during an earthquake. And S waves are both body waves, and S waves are secondary waves, so they're slower. So P waves, like the way to differentiate them is like P waves are primary waves, meaning that, well, they're the ones that arrive first, as aforementioned, and they can move through solid rock and fluids like water or like liquid layers of the earth, so they can go deeper than the crust, and they can push and pull the rock. So it sort of moves like just like sound waves push and pull the air. It's similar in that aspect. And S waves are secondary waves, as I mentioned, and they can only move through solid rock. Like, they can't go through liquid mediums or such. And it's this property of S waves that sort of led seismologists to conclude that the Earth's outer core is a liquid. S waves move rock particles up and down or side to side. It's just like perpendicular to the direction that the wave is traveling. Is traveling in. So it's like the direction of wave propagation. And surface waves only travel through the crust. Yeah. There are also like waves called, so for the surface waves, there are waves called um, so for surface waves, there are waves called love waves and Rayleigh waves, but I don't think you need to know about them. And oftentimes there will be a graph from a seismograph, and you will be required to analyze the seismic waves based off of the drawings. And for volcanoes, oh, hold on. Oops. Sorry. And for volcanoes, like, oh, um, yeah, for volcanoes, you should study the types of lava and also the types of eruptions, such as strombolian and volcanoes like shield, cinder cone, and composite volcanoes. And there's like 3 different types. They're the primary types, so study those and like their characteristics. And for lava, there are 2 primary types. One is called AA lava, and one is called Pahoho lava. You can differentiate them because AA lava is typically very chunky and angled. Like it has a lot of rocks and different rubbles in it. While Pahoho lava is it's interesting because it's very thick and flowy lava that can go up and downhill. Like it can go both ways. So once you see those pictures, it'll be probably pretty obvious which is which. As for lava, like I think you should know this already, but like magma is when lava is underground, and it's only called lava when it reaches above the surface. Additionally, go over like how these natural phenomena incited by these tectonic plates can like affect their surroundings, like including people, flora, and fauna. And you should study both the positive and negative impacts. Like one such example, volcanoes. So the major factor of volcanoes that like kills a lot of people every year, like when they explode, and you probably know that it's called pyroclastic flow. Pyroclastic flow is basically a very, very dense cloud of hot ash and lava fragments and gases, and they're ejected from the volcano at a really high speed. So it just comes rushing over and barely any time to react. But there are also benefits to these volcanic eruptions. So there's like positives and negatives, right? So a volcanic eruption, as you know, it can like destroy everything, but also it can like restart succession and provide more fertile soil for new life to grow. So in the case where there's like a really infertile land region that's not growing anything, a volcanic eruption can really just restart life for the organisms there. So now I'll go over some sample problems that you might see in the test. Okay, so problem 1 asks, based on the image on the right, which is this image, where is an earthquake least likely to occur? A, 1, B, 2, C, 3, or D, 4. So they're labeled on this photo. I saw this problem appear in a couple tests, so I just listed it here. And as you can see, 1 is in a pretty flat region. 2 is at an ocean trench. 3 is at some sort of subduction zone, and 4 is at an area where there's a hot asthenosphere. So it should be pretty obvious that 1, which is A, is the answer, since all the other places are pretty active. Yeah. And for problem 2, it asks most tsunamis occur blank. A, in the Pacific, B, in the Atlantic, C, during hurricanes, or D, in the Indian Ocean. So the answer to this is A, in the Pacific. And see, in these types of problems, you need to have background knowledge of like activity in all these regions, and also maybe about like basic like tectonic plate boundaries. And you can see probably in the Pacific is most active since there's a lot of activity in there with the Ring of Fire and all. So these are examples of pretty easy test questions. Like the actual tests will be much harder, so just be prepared for those. I'll now introduce some possible resources that you can reference. Oops. So be sure to check out the resource portal, which should be shared with you. It'll have guidelines and also like links and such that you can refer to. Also, check out the Scioly wiki page. It's like tectonics is like a new topic, I think, so they don't really have much information on it, but they mentioned that they'll include earthquakes and volcanoes, so study there. They also have links and sources for you. Also, check out the test base, which is listed under Test Exchange on the website. And over there, they also don't have tests, but they'll have the earthquakes and volcanoes test. So check those out because they'll probably appear on the tectonics test. Also, check out the SOINC page. It's the official website, so it'll definitely have information for you. I don't think it's updated yet, but it'll update soon. Also, this USGS website, this I put the link below. It's pretty useful. It has like all the history of plate tectonics to like the types of volcanoes and earthquakes and such, and also like benefits of those. And I put edX and Coursera, so they're like online learning websites. So you can just sign up for an account and like go look at the lectures. They have a lot of information that you can use regarding tectonics and just topics in general. So if you have any questions, please put them in the comments, like general questions about the test, and I'll try to answer them.